を向けてまいります。大きな津波が迫っています。まもなく捉えました。大きな津波が2波3波に確認してできますでしょうか。大きな津波が
Tsunami! There's a tsunami!
Oh my god! What do we do? What do we do?
I don't know! We have to get to higher ground.
Let's see how long it'll take for the wave to come. Hurry fast! We need to find the frequency.
I know. I'm trying to find what amplitude the waves are.
I'm so glad we made it safe ground away from the tsunami.
I know, me too. Now, I want to go over this wave that we saw really quick. So, this is one wavelength. What is a wavelength?
Well, it's the distance between successive crests of a wave.
And what is a wave?
Well, that's a disturbance that carries energy throughout matter or space. Don't you remember?
Oh, yeah, that's right. Okay, so now I want to label on this wave, what is a crest?
Well, it's the top of the wave.
Okay, so the crest would be right here. And what is a trough?
It's the bottom of the wave.
Okay, so then the trough would be right here. And what is the amplitude?
That is the maximum extent of a vibration or oscillation measured from the position of equilibrium.
Got you. Okay, so the line being the point of equilibrium, the amplitude would be right here. Now, lucky for us, when we were down at the shore, I found the amplitude, and it is 7 meters. So, also, when we were down at the shore, I found the velocity, which is 11 meters per second. Now what I want to do is find the frequency. And the equation to find the frequency that we're going to use will be lambda is equal to velocity over the frequency. And we'll just go like this. Now we have lambda, which is the wavelength, and that is 0.2 meters. So we're going to plug that in. And the velocity. And that is going to come out to 2.2 hertz. So we have our frequency, and now I kind of want to find the period. What is that?
The time it takes to complete one cycle.
Okay, so the equation for that is time is equal to 1 divided by our frequency. So, frequency being 2.2, that will come out to 0.45 seconds. This is our time, and this time is how long it will take the wave length to go through.
So there is a transverse wave and a longitudinal wave. And the transverse wave, in a transverse wave, particles go up and down, and the waves go left to right. I never knew that. Yeah, well, also in a longitudinal wave, it is left to right for waves and the particles. Okay. But water waves, like the waves in the tsunami, go left to right and up and down. So that's what we saw down there. Now, I'm figuring that we're in high enough ground, so I think we're safe.
Okay, I'm going to tell you a little bit about the Japan tsunami. And the earthquake that made the tsunami happen was the 4th largest ever. And about 3,000 confirmed dead and suspected about 10,000 missing or injured or whatever. And easily over $100 billion worth of damage so far was detected. And the quake triggers the tsunami up to 10 meters, which waves sweeping away homes, crops, vehicles, and submerging farmland, and scores of locations on fire, including a large waterfront area in northern Sendai City. The tsunami of 7 meters later hits northern Japan.
The wave crashes onto land because of how much energy is pushing on that water. It just flows onto land. It doesn't stop because there's more water behind it with so much energy pushing. This is what causes the destruction. It's not a massive wave that swallows buildings whole. Instead, it is the energy behind the wave that does all of the damage.